In the last day, for your class, we started organic chemistry after discussing some part of some summary related to your inorganic session. So when we are moving to the organic chemistry, I explained the importance of the organic chemistry using the A-level paper. I mean 2019 A-level paper. So you learned we are having 10 MCQs, one structured essay question and one essay question. So in the essay question, it is specific that the conversion is a tough part, an important part in the essay paper, the conversions question. Okay. And then from the last week onwards, we have started the nomenclature lesson. So we discussed what is benzene and what are the structures of benzene. We learned benzene means C6H6. And for benzene, Kekulé, the scientist Kekulé, he has derived some structures. Those are called resonance structures. And he identified the real structure was not any structure that we are drawing like a linear structure. Can you remember we have drawn some linear structures for benzene using triple bonds and double bonds? But why the benzene is not having a linear structure? Because in real benzene, in actual benzene, we can't have double bonds because the actual compound is not reacting with bromine. Actual benzene is not reacting with hydrogen. So we have to skip the double bonds, we have to skip the triple bonds. That's what Kekulé suggested, one of the important structures for benzene, which is the Kekulé structure like this. Okay. So this is the Kekulé structure for benzene. Not only one structure, okay. We have resonance structures, so we can obtain this structure. For benzene, one by one, you have double bonds. So here you can see the single bond, here you can see the double bond. So the actual bond is the partial double bond. So actually, we are having a partial double bond in between here. So you don't want to worry about this structure. Sometimes you may think now in this benzene, you have the double bond. No, in benzene, we don't have double bonds. Okay. If there's a statement in benzene ring, we have 3 pi bonds. Okay, we have 3 pi bonds, or we have double bonds. That's not available. Okay, actually in benzene ring, double bonds are not available. No double bonds, because we can't say this one as a double bond. We should accept there's a resonance. So there's a double bond, there's a single bond. So the actual availability is a partial double bond. So we have drawn 6 partial double bonds or 6 partial bonds around benzene. And then I told this was the actual structure for benzene. That's what sometimes when we are summarizing benzene, we draw a hexagon like this and drawing a circle inside that indicating this. Yeah, so this is the actual structure. This is called the resonance hybrid of benzene. Okay, we learned that thing. Apart from that, I started hydrocarbon session. So that is called aliphatic hydrocarbons. So simply aliphatic hydrocarbons means open chain hydrocarbons. I mean linear hydrocarbons. So in open chain hydrocarbons, in linear hydrocarbons, we have 3 types. We're having 3 types. What are those? Alk, alkenes, and alkynes. So simply alkane means we have carbons and hydrogens. In hydrocarbons, we have carbons and hydrogens connected with single bonds. They can be carbon-carbon single bonds or carbon-hydrogen single bonds. But when we are moving to alkenes, the specialty is we can observe a carbon-carbon double bond amongst the other bonds. Only one carbon-carbon double bond. So all the other bonds should be carbon-hydrogen. Okay? And then in alkyne, you can observe one carbon-carbon triple bond in linear structures. And then we have derived structures for alkanes, alkenes, and alkynes. Before that, I suggested that alk means the number of carbons. So I have given the names. Can you remember? So for one carbon, what was the name? Okay. So when you have a single carbon, the name was meth. Okay. The name was meth. This is very important to keep it in your mind. Okay. Definitely you have to by heart these terms. Then when you have 2 carbons, it was eth. 3 carbons, prop. 4 carbons, bute. 5 carbons, pent. Hex, hept, oct, non. Okay, that's enough. So depending on the number of carbons, we can give names for alkanes, alkenes, and alkynes. As an example, methane, okay, ethane, propane, butane. Can we have? Do we have methane? No. in a certain alkene or a certain alkyne, at least there should be 2 carbons. In order to draw a structure of alkene or alkyne, you have to have 2 carbons. Clear? So now methene is impossible. Methane is there, methene is impossible because in methene, you have only 1 carbon and you are suggesting that it's an alkene. It's impossible. So the first alkene would be ethene. Then propene, butene, pentene, hexene, heptene, octene, likewise. And I advised that when we are writing alkenes, it is very important to write the location of the double bond because the double bond can be anywhere. But when you are drawing the structure, it is better to indicate the location. As an example, it was 2-butene. 2-butene. So this 2-butene suggests we have 4 carbons and then the double bond is available in between the second carbon and the third carbon. I told that we are writing the lowest number here. Okay. In the carbon-carbon double bond, you have 2 carbons. So there should be 2 numbers. But considering the 2 numbers, we should write the lowest number here. 2-butene. So you should have a proper idea about this compound while you are looking at the name. But means 4 carbons. Ene means a double bond. 2 means the double bond is at the second carbon and the third carbon, in between the second and third. It is not in between first and second. If it is between first and second, you should write like 1-butene. 1-butene. Or sometimes we are just writing butene or normal butene. N-butene. Okay. So there are certain terms you will be realizing those. So I explain the idea. So when you are writing an alkyne also, it is very specific to mention the location of the triple bond. As an example, 3-heptyne. 3-heptyne. So heptyne. Yne means a triple bond. Hep means 7 carbons. So then you have an issue where we have to put the triple bond. So there's no issue. You have definitely you have to take the triple bond towards the third carbon and the fourth carbon. Okay? This is the lowest one. So it's very simple. Okay. So learning organics means just learning like a language. Starting from the very first day, you have to be there. Just think you are learning Chinese or Japanese or any other language, okay? German language. Okay. So in that case, first of all, you have to know the alphabet name. So then from there, small words and then phrases, some sentences, and then you will be getting the other stuff. So likewise, organic is also just like from the beginning. Okay? I can teach organic to 2023 students also. Because for this organic chemistry, you don't need any inorganic part or any physical part. Okay, so we can continue. Really sorry for the background noise. That's a delivery vehicle. Okay, yes. Now then, I'm supposing to start the homework discussion. So before that, I want to explain about the equations. Now, alkanes, what was the common formula? That is CnH2n H2n plus 2. You have to keep it in your mind. Alkanes, the common formula. It's easy. Then in alkenes, it was CnH2n. Alkenes. And when you move into alkynes, that is also very simple. You have to do only one thing. Just put subtraction here. CnH2n minus 2. That's it. Okay. So sometimes you may be thinking about complex structures. Okay. Like triple bond with 2 double bonds. So that is a complex compound. Now, generally here we are referring an alkyne means there can be only 1 triple bond. All the other bonds should be single bonds. If you are having a double bond, we can't specifically say that as an alkyne. It's a complex compound, but we will be naming that compound at the end as an alkyne because of the priority. There are different priorities for alkenes and alkynes. Always alkyne is more prioritized than alkenes. So in a single compound, if you have a double bond and a triple bond, as the triple bond is more powerful, I mean, the triple bond is more activated inside the compound, we are naming the compound as an alkyne. You'll be getting those stuff later, okay? But it is not relevant to your L-level syllabus. Okay, this way, I'm going to discuss the answers for your homeworks. You have sent those ones. I have just taken a look. Okay, check up, but as I'm discussing in the class, I identified most of the students who can cope with the session easily. Okay, so I want to examine how you are writing, how you are dealing with the organic writing. So it is better. So let's see. Okay, and in today's session also I'll be giving some chance to draw some structures by yourself and send it to me. Okay, so the first structure, write the names of following. I'll start with that. So this was CH3, CH2, 6, CH. So you have to write the name. Yeah, I have given the structural formula. This is not the molecular formula. Okay. So when you are looking at the structural formula, we can see here 6 carbons, and here 7, and here 8. Okay. We don't want to draw this and count the number of carbons. Easily we can recognize here 6 carbons, 7, and 8. So 8, then we have to worry about, we have to find out whether we have a carbon-carbon double bond or a triple bond. Whether there's no carbon-carbon double bond. Why? Because if there's a carbon-carbon double bond, definitely in the structure you have to indicate it. Without indicating a carbon-carbon double bond or a triple bond, you can't draw a structural formula. That's incorrect. So this suggests it's an alkane. Okay. So then we have 8 carbons. It should be octane. Okay. So the first answer is octane. Please check your answers yourself. Put a tick. Octane. Okay. So it is not 2 octane or 3 octane. It's octane. So if you have any issues, please use the chat and send me a message. I can answer your questions. Okay. In the live session. So number 2, that is simple. CH3, CH2, CH double bond CH, and CH3. Okay. So by looking at the structure, it is clear this is an alkene. It's very important to number the alkene. So you can count the carbons. I know 1, 2, 3, 4, 5. 5 means pent. So sometimes you have written this is pentene, but it is not the exact answer. Okay, pentene is not the exact answer. You have to give the location of the double bond. So when you are giving the location of the double bond, okay, you have to be very careful when you are numbering it. Why? Because you can't number to any direction, left to right or right to left. There's a certain criteria you have to follow. What is that? Always give the lowest number to the carbon-carbon double bond. So how we number it? 1, 2, 3, 4, 5. Okay. If you are numbering in the other way, you won't be giving the lowest number to the carbon-carbon double bond. Why? Now here you can see in the carbon-carbon double bond, I have a lower number, a lower value, that is 2. But just think you are numbering in the other side. 1, 2, 3, 4. So then you don't have a lower number. That means you are having 3 and 4. So you can decide when you are having 3 and 4 and 2 and 3, which one is the lowest case. Okay, that simple thing is here. So this is the correct order of numbering. And then you have to write the name, start with the location of the double bond. So you can write 2, small dash, compound is pentene. Okay, it is 2 pentene. I have seen some students, they are writing 3 pentene. Why they are writing 3 pentene? Because I think they have numbered in the other way. Isn't it? Then make it a 3 pentene. 1, 2, 3, 4, 5. The numbering in the proper direction, left to right. You are writing left to right now. So your numbering also left to right. Okay. In numbering, I can't say whether you have to number left to right or right to left. Okay. It depends on the structure. What we have to do, we can write these things if you want. Okay. We have to give the lowest number to the carbon-carbon double bond. So how we find the lowest number, how we find the direction, actually I think it's the common sense, or if you can't find, try to number it in both ways and then just contrast. That's what I have to say. Okay, 1, 2, 3, okay, you get 3 from this direction here. Okay, so 3 and 4 from the other direction. Shall I number it in the red pen? Because some students, I have to explain for some students up to this level. Okay? But for certain students, I don't want to explain. But this is a group class, so I'll be explaining for everyone. Okay? Because they are trying to get this lesson themselves. This is an online session, so they need more explanations, more attention. So 1, 2, 3, 4, 5. So you can search when you have 3 and 4, and when you have 2 and 3, which one is possible? The rule suggests use the lowest number to the carbon-carbon double. So the lowest category is this. Here. So just skip this. That's incorrect. Here. You can write this name in another way. Obviously, pent 2E. It's also possible. Okay. I'll explain these rules when you are giving when you are writing the names in the structures. Okay. Still, these are not IUPAC names. Okay. These are just general names or some odd names of these compounds. Okay. According to the IUPAC rules, we'll be discussing this 2-pentene or pen-2-ene, both are correct. Use a dash there. Okay. If you have any questions, please ask. So I have discussed 2 questions related to the last day's homework. And when I'm giving homeworks, I'll be giving a bit difficult homework. I mean, it's not difficult. I'm giving a challenge, not giving some easier ones to do it in 10 minutes. Always I'm trying to give, this should be the level that you have to reach. See, that's what I'm doing. I'm giving like 10 questions and I'm giving the 10 questions in the best levels as it is possible. Then if you have reached to that level, just think you're at the best level, you're at the top. You can manage the other things without issue. Okay. So the third one, CH2, CH2 thrice, CH3. So can you see how I'm pronouncing that, like CH2, CH, CH2 thrice, CH2 thrice, CH3. If you want, you can expand this. Make this one expand. So carbon-carbon double bond means this one. What means by these 2 hydrogens? These 2 hydrogens means the 2 hydrogens which are attached to this carbon. Because I told always carbon should have 4 bonds. 1, 2, 3, 4. That's CH2. Then CH. So you can put this CH. Okay, always remember, around carbon you should have 4 bonds. Now 1, 2, 3, you can have only 1 bond. Okay, don't put another bond like this. It will exceed the octet. Okay. So this is incorrect. If you are writing a hydrogen like this. So always get that sense to your mind. Okay. So in some classes I have done the conversions part, but sometimes the students, they are writing some compounds, okay, exceeding the octet. It will lose your marks. Okay. So then this is CH2 thrice. Okay. I'm trying to give the expanded version of this. CH2 thrice means CH2, this CH2, and this CH2. So it is CH2 thrice. And then this CH. This CH. Like this. So this was the actual structure. Okay. No need to draw like this, but I just want to explain you how to draw this structure. Okay. And then you can number it. Keep remember when you're numbering, in which case you have to number. When you have a double bond and triple bond, you have to number before writing the name. Now, understand the type of the question. They have given the structure and asking you the names. This type. And then the second type, later on we'll be discussing. And there we have given the name and asking you to draw the structure. So 2 types. So 2 functions we have to follow. Now in this one, we have to number. And when you're numbering it, you have to give the lowest number to the carbon-carbon double bond. So from where to where we have to number? From here to here. 1, 2, 3, 4, 5, 6. So you should understand there are 6 carbons. Here, 6 carbons. So 1, 2, 3, 4, 5, 6. So then the double bond is available in between the first and second carbons. So we are writing the lowest number. That's 1. So what we have to write, 6 carbons means hex. 6 carbons means hex. And the double bond is available in the first carbon. So you can write hex 1E. Okay? Or 1 hexene. 1 hexene. If not, you can write just hexene. Okay? If I have written hexene also, that's also correct. Because hexene suggests it is 1 hexene. When there's 1, sometimes we don't want to write it. Okay? In general case, we write this one as N-hexene. N-hexene means normal hexene. But this is general nomenclature, empirical nomenclature. Okay? No need to follow this. Just you have to know it. N means normal. Okay? Yes. So then I'm not advising you to draw like this. Because it will take a lot of, okay, it will waste your time. So it will take a lot of time. Okay? So however, try to manage this situation. Now here 2 carbons And here 3 carbons means you can count. So 2 plus 3 means 5. 5 plus 1 is 6. So you have 6 carbons means hex. And you can see a double bond that's in. Then just find the location of the double bond. It's in between the first 2 carbons. So give the lowest number. That's it. Okay, so I'm going to erase this. If you want anything, you can get screenshots. The third one I have discussed. Yes. So the nomenclature lesson is just like this. It's very simple. Okay. So this is the foundation to organics. Don't just think this is very simple. There are some issues with this. Let's manage. Okay. Now fourth one. CH3, CH2, C triple bond C, CH3. Okay. So let's name it, number it. Okay. So how we number it? From where to where? Always not left to right, not right to left, but the direction which gives the lowest number to the triple bond or the double bond. Okay. Now we have the triple bond. So it is very clear. 1, 2, 3. That would be the lowest case. Because if you are moving here, 1, 2, 3, 4. Here you get 3, 4. But from this way, you get 2, 3. So which one is better? 2, 3. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So this is 2 and 3. Yeah. Okay. So what's the name? Carbons 5. Carbons 5 means pent. Pent. And I can see this is an alkyne. So it should be pentyne. And is it which pentyne? It is 2-pentyne. Good. So you can write 2-pentyne. So it's better. It's important to write a dash. Okay. Don't keep a space. You're violating the rules then. So write 2-pentyne. Is it can we write this P as capital? No, just write simple letters. All the letters are simple. Okay. 2-pentyne or pen2-ine. It's also correct. Okay. If you're writing a capital letter, just write the capital letter for the first full letter. Okay. First one, it would be capital. It can be capital. Otherwise, write all the letters as simple. Okay. In IUPAC nomenclature, the first letter we can write as capitals. All the other letters should be simple. If not, we can write all the other letters as simple. That rule is not just taken a serious rule. Okay? Taken as a serious rule. I know in biology, in nomenclature, the first letter must be capital. Okay, that thing. But this is IUPAC nomenclature related to organic compounds. Fourth one, and then I have the last one to discuss. Okay. Yes. Okay, Uda. The last one, the fifth one here, CH3, CH2, twice, C triple bond, C, again CH2 twice, CH3. So I would like to draw this, not the structure, not the geometry, but the structural formula in an expanded way. Okay, now this is just compressed. Okay, so I can expand this, the structural formula. CH3, what means by CH2, CH2? CH2 twice, it means CH2, CH2. And it's this carbon, C triple bond C, this one. And then CH2 twice again. So, okay, when you're writing the triple bond, please use the single bonds in order to hang it to the other parts. Okay, either sides of the triple bond, use the single bond. And CH2, CH2, it's CH3. Then the most important part is numbering. Okay. So when we're numbering, if you are getting the same number from left to right or right to left, so if you're getting the same number, it's the same compound. No issue, just number it. That means from this side, you get 3, 4. From the other side, you get 3, 4. Then number it as 3. Okay. From 3 and 4, we get 3 in it, lowest number. So number it. Don't think of any side. It's symmetrical. It's called symmetrical. Okay. I don't know whether this is like that. 1, 2, 3, 4, 5. From that side, you get 5, 4, 5. From the other side, 1, 2, 3, 4, 5. Yes, exactly. So it's a symmetrical compound. Okay. So then just select the lowest number and write your name. That's it. Okay. So this is 4 dash. What is this? Alkyne. How many carbons? Sometimes in this mode, you can't count the carbons, but we can. Okay. Sometimes it's difficult. 1, 2, 3, 4, 5, 6, 7, 8. 8 means oct. 4 oct. Triple ine. 4 octine, oct 4 ine. Yeah. Okay, so those 5 structures, that's it. Okay. So if you have any issues, please tell me. Now check your answers. So I'm asking to write this name. Okay. So if you haven't keep this space, sorry, this dash, keep that. Okay. Don't keep any space. Okay. So I'll ask some students. Disela, how was it? Is it clear, this part? Any questions?
No, sir. It's clear, sir.
Okay. Yes, great. Kisara, how was it? Any issues?
No, sir. Everything is okay.
Okay. I'll finish the homework soon, and I'll try to give some examples here and carry on the lesson furthermore. Okay. So if you have any issues, just tell me. Yes. So we can draw the formula for following. Okay. Yes. Definitely in organics, you have to practice by doing examples like this. It's very important. Okay. Practice is really important. As I have done the third chart for one class, we have the third chart. So from the third chart, I have given 16 conversions only from the third chart. So we have discussed the 16 conversions, and again I have given another 15 conversions from the same chart. So when you're doing more and more conversions, the paths, the reactions will be more efficient. You can manage the reactions very soon, okay, from those stuff. Okay, so that's what the activities are really important. If you want to write a book, you can get the resource book and try to copy it. And you can get the Organic Chemistry International books, FINA, Volume 1, Volume 2, Organic Chemistry by Solomons. Okay. There are so many books. But reading books will not improve this. Just you have to face questions, practice the points that you have learned. 2-pentene. 2-pentene. Okay. 3-heptene. 3-heptene. Non-N. Non-N. 2-hexyne. 2-hexyne. Oct-3-ene. Okay. Simple stuff. Now, pentene. Okay. 2-pentene. So then how we draw the structure? Actually, when you're drawing the structure, some students, you have drawn the structure like this. So, okay, in this format, and then write in the double bond and write in the hydrogen. That is called geometry. That is not the structure, that is geometry. But we are expecting the structural formula at the end. So I'll draw the geometry here and obtain the structural formula, but try to manage or try to get the structural formula at once. That's the ability. That's the talent that you are developing. Okay. We don't want to draw structures like this and obtain it. Okay. From your mind, you have to summarize it. You have to shorten it if it's possible. I just think I'm telling about a decade. So you are drawing 10 carbons and creating the hydrogens and all the double bonds and designing that. But if you can just write with a shortened form like CH2 6 times, it is the most enhanced form. Now 2-pentene means 5 carbons, it's okay. Then do we have to number this? Yes, when you're drawing it, you have to number to a certain direction. To which direction? Now here I can't say any direction because you are drawing your own compound. Sorry, if you are numbering it to left to right or right to left, it's correct. That means here we have 2 compounds. Okay, just think from left to right when you're numbering, if you get the second carbon here, from the right to left, you are getting the second carbon here. So if it is not symmetrical, we'll be having 2 structures for this. Both are correct. Okay, okay. Now 2-pentene, 1, 2, 3, 4, 5. So at the second carbon, okay, 2 means in between 2 and 3. Okay, so at the second carbon, you have to have a double bond. And then you have to complete. When you're completing, here we have to put 3 hydrogens. Okay, that's how we get 4 bonds. Just see, 1, 2, 3. 4 bonds around carbon. Now around this carbon, already you are having 3 bonds. 1, 2, 3. So how many bonds we have to apply? only one bond. Okay, just apply this one. Here 1, 2, 3. 3 bonds are there. Just apply one more bond. 4. Then here 2 bonds. So you have to apply another 2 bonds like this, and here 3. So this is called the geometry. This is the geometry. I'm not expecting the geometry actually. I'm expecting this answer. Okay. How to write the structural formula? See here how to shorten CH3 like this. And then this double bond. Okay. Definitely you should write the double bond. When you're writing the double bond, you just use the single bond just before and after the double bond. Okay. That will make the compound bit an interesting view. Okay. Put a plus and a nice view. When you're writing the double bond, just put the single bond start and the end. Okay. Just before the start and just before the end of the double. Okay. Like this. CH3. Now I'm going to write the double bond. CH, double bond, CH, and then the single bond. And then I can write it together. After that, no need to mention these single bonds. Okay. CH, then you have to CH2, CH3. Just link it like this. But I have seen some in some cases you are not writing this single bond. It's okay. Okay. Then you can write like this: CH3, CH, CH, CH2, CH3. Both are correct. Okay, no issues. Okay. And we can't say this is incorrect. And then if you are numbering in this way, okay, let's think you are getting 5 carbons, 1, 2, 3, 4, 5. If you are numbering in this way, here you get the double 2 pentane between 2 and 3. So then how to complete the structure? You have to put 3 hydrogens and then you will be getting this compound. CH3, CH2, CH, double bond, CH, CH3. Both are correct. Okay, see whether you have taken these answers. So if you have written like CH2 here, that's totally incorrect. You don't give marks. CH2 you can't write. Okay, when you have a double bond, how you write CH2 at the center? Okay, at the terminal you can write when you have a double bond. But at the center you can't write CH2 is incorrect. It is exceeding the octet. You should know already we are having 1, 2, 3 bonds. So then with this hydrogen that will be 4. So if you are mentioning it is CH2, that will be 5. So please think it at that time. Okay. Yes. So then I will draw the structure soon. Because the first one I have explained well, then the other one I will be doing a bit fast. Okay. So you should be able to manage that. It's 2-pentane we discussed. What about 3-heptene? Let's draw it soon. 3-heptene. 1, 2, 3, 4, 5, 6, 7. So that is 3-heptene. So ene means a triple bond. Ene means a double bond. So where is the double bond? 3 means the lowest number. So the next number will be 4. So you should obtain 3 and 4. Between 3 and 4, you have to obtain a double bond. Okay. That's what you have to do. 3-heptene. 1, 2, 3, 4, 5, 6, 7. Okay, so then you can number it in any way. 1, 2, 3, 4, 5, 6, 7. So in between 3 and 4, we are arranging the double. Yes. Okay. In the way also, if you have numbered like this, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3. When you're numbering in the other side, may pattern number karo, 3-heptene means between 3 and 4 you get the double. Both are correct. So then you have to complete the structure. How to complete? Okay. In a case like this, use a single bond CH3. Okay. And then this should be CH2. And when you have the double bond at the center, already you're having 3 bonds. Use another hydrogen like this. Okay. I'll write it again, but yeah, I'm completing the sketch. 1, 2, 3. Yeah, another hydrogen should be there. You can write the hydrogen upwards. No issue. Okay. Now here CH2 and here CH2 and again CH2. Okay. So shall we write this compound here? CH3, CH2 dash CH double bond CH, CH2, CH2, CH3. This would be the structure. From this one also, you can draw it in the same manner. Okay, CH3, CH2, CH. Okay, shall I draw it like this? Make it like CH3. For this one, you can write CH2. So I'm writing here to here. Okay, to the direction that I have numbered. So then this is CH. Okay, because we are starting the double bond, CH. And then this one should be CH2, this carbon again CH2, this carbon again CH3. So it's better to improve this talent. Okay. So if you have drawn in this way, try drawing the other way also. Just now. Okay. You can draw both structures. You can number it in the other way and get the other structure. So if you have drawn the geometry, try to write the structural formula. Because from today onwards, you have to practice the structural formulas. These ones, not the geometries. You can't expand these bonds with hydrogens and draw it. Okay. The next one, it's non-N. So non-N is a bit simple, no? Non-N. Non means 9 carbons, N means an alkane. So there's no double bonds and triple bonds. We don't want to worry about the locations. Just write 9 carbons. But when you're writing 9 carbons, don't write CH3, CH2, 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 CH2. Then you are thinking whether I have completed the CH2s. Okay? And then just counting again and drawing it. But it's really simple. Okay? If you can draw CH3, okay? And you know to this side also we get CH3. So at the center, we can write CH2 times, but it's the value. Okay. So then when we have 2 carbons either sides, non-N means 9. So 9 dash 2, that's 7. So that is CH2 7. That's it. So do we have to draw CH3, CH2, 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 CH2? No. This is exactly correct. Okay. Don't try to expand this, don't try to compact this furthermore. Okay. I've seen some students like CH3 twice, CH2 7. Don't try to expand it that much. Sorry, compress it that much. This is enough. Okay. How we read this? CH3, CH2 7 times, CH2 7 times, CH3. And this should be your final answer. If you have not taken the final answer, please adapt it to this level. This is what I am expecting. So if it's better that you have drawn the geometry, structural formula and everything, but this should be the final view. Okay. 2-hexane 3-octet. So I'm going to draw it. Yeah? So now you can feel whether these are difficult or not. Okay. These are not difficult, really simple things, but more improvements will be getting. So question here. Can't we write non-N as C9H20? Great question. Okay. Non-N, if you are writing C9H20, you can remember non-N was, non-N is an alkane. So in alkanes, what was the common formula? CnH2n plus 2. So here you can use the common formula and write it. But keep remember, this is the molecular formula. This is the molecular formula. In the exam, if they are asking the molecular formula, you can write it. But this is not creating any sense how that is arranged. But it is better if they have asked the molecular formula, this is definitely correct. But in my question, I think I have highlighted draw the structural and molecular formula. I have given the term called structural. So definitely the structural formula would be this one. I'm not explaining the molecular formula here because it's very simple to write. For heptene, if you are writing the molecular formula, C7, how to get the number of hydrogens? You know, for alkenes, the common formula is CnH2n. So when you have 7 carbons, the number of hydrogens is 14. Okay. Pentene, C5, H10. So this is molecular formula. Molecular formula, again the molecular formula, but we are trying to focus about the structural formula. So it is better to have both views, the molecular formula and the structural formula. In the last day session also, I have highlighted what is the difference between the geometry, structural formula and the molecular formula. So try to identify the variation according to the question we have to fix. Yes. So I'm going to discuss the last two. Without the single bond, isn't it correct? Which one? This one. Correct. Okay. Make a single bond again. CH3. Namna single bond again. Class center. CH2 7. CH3. This is also possible. I have seen this. Okay. Both are correct. So just writing patterns. Okay. Writing patterns. This is more better. at this way, at this version, the last one. Okay. So let's discuss the last two examples. Huh? Okay. Two hexane and 3 octene. Okay. Just now also you can draw this and you can obtain the final structures. So my final point is write the molecular formula and write the structural formula in a compacted form. Yes, hexane. Hex means 6 carbons. Hex means 6 carbons. 1, 2, 3, 4, 5, 6. Okay. So then you have to number. Generally, I'm numbering from left to right, okay, because it is not essential to write from right to left. I'm just numbering from one direction. So then 2 hexane means in between the second carbon and third carbon, you have the triple bond. Ine means the triple bond. Ine means the triple bond. So then how to finalize the compound? We have to have hydrogens around the carbon. So now this carbon is now here only 1 carbon. In order to make 4 bonds around that, you have to keep 3 hydrogens like this, CH3. And here single bond, triple bond, a single bond. And then here this carbon is having 2 bonds already. So we have to complete the other 2 bonds, like CH2, and here CH2, and here CH2. But keep remember, this is geometry. This is geometry. This is not the shape. Huh? If you are drawing the shape, you have to draw it in accordance with the exact bond angles. I mean tetrahedral, trigonal plane. Those ones you have to show. So I mean this is not the shape. It's called the geometry, general geometry. Okay? If you are drawing it accordance with the shape, you should know this is 180 degrees. And here 109 bond angle, tetrahedral, tetrahedral, tetrahedral. Okay? So we'll be discussing those issues, the bond angle, bond length, hybridization, in the 5th part of the organic session. I mean properties of organic compounds. But until then, it's better to draw like this. But I asked to draw the structural formula. So how to draw the structural formula? It is CH3, C triple bond, C, CH2, CH2, CH3. Okay. So you can put 2 single bonds. It will make this one be clear. Okay. Either sides. Like this. Now you can see which one is more clear. Okay. Generally, when we are writing compounds like this, it is easy to recognize the triple bond. But here, this is a bit compacted. Both are correct. Okay. I don't have any issues with this. Yes. So if you are numbering in the other way, that's also possible. Shall I draw it in the other way? 2 hexane, 1, 2, 3, 4, 5, 6. Okay. In the Arabic way. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. And there is 2 hexene. And the second and third carbons, you should have the triple bond. Like this. And then we can complete it here itself. Okay? CH3. 4 bonds, no hydrogens. 4 bonds, no hydrogens. 2 bonds, 2 hydrogens. Like this. 2 bonds, 2 hydrogens. 1 bond, 3 hydrogens. Like this. If you want to shorten it much more, you can do a thing like this also. CH3, CH2 twice, C triple bond C, CH3. So these are structural formulas. If you are writing the molecular formula, hex means 6 carbons, ine means, triple bond. So what should be the common formula? As they are given, I have given it CnH2n minus 2. So C6, H2n means 6 into 2, 12. 12 minus 2, 10. So C6H10. That should be the answer. Okay. So I think that concept is clear to you. So, shall I get the next one? Oct3ene. Oct3ene, that's the last one. So if you have written the geometry like this, please adapt to here. It is structural formula. Please try to come up with these structures. Yes, so it's time to discuss the last one here. Oct 3 in 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So actually, in a structure like this, you won't be getting more than 8 carbons. Definitely, the maximum number of carbons you'll be getting is oct 8. I haven't seen that you are getting dec and known that much of carbons in an organic nomenclature question. So oct 3 in, so you have to number it 1, 2, 3, 4, 5, 6, 7, 8. 3 in means in between the third and fourth carbon, you have the double bond. In means double bond. 3 means should be 3 and 4, in between 3 and 4. Okay, so you can complete the other structure. Here itself you can complete, or you can draw it another way. Make a complete pulang. If not, you can draw it again. So shall I complete here? CH3, and you have a single bond, it should be CH3. And then this is also a single bond at the center, CH2s. And then here 2 bonds, and there should be hydrogen. 1, 2, 3, 4. Just count and put it. Okay? If you are writing 2 hydrogens, that's incorrect. 1, 2, 3. This hydrogen. 2 bonds. 3, 4. Okay. 2 bonds. 3, 4. 2 bonds. 3, 4. And here 3 bonds. Okay. But this is geometry. Yeah? This is geometry. I'm not expecting this one as your final answer. So what would be the final answer? It's better to compact it and write. So CH3, CH2, dash, CH, dash, CH. Here, I'm here. Then you can I can see that CH2, CH2, CH2. It's repeated 3 times. No need to waste. Okay, just CH2 3 times. Okay, and then small dash. I'm keeping the dash in order to write it completely. If not, you can miss that dash. No, that's no issue. Okay. Sometimes I'm writing that dash in order to explain it correctly. But if you are not writing this dash, this will be more compacted. Okay. So that's not making any sense there. So I'm writing it always. You'll be getting marks for that. Okay. And it is clear to us also. We can confirm our own answer. Okay. Yes. So that's it. Now molecular formula. Oct. Oct means 8. En means CnH2n. C8H60. Okay. So I want to get some idea about this discussion. Yes. Ashanika, how was it? Any issues? If you have any questions, please ask from me.
No, sir, it's clear.
Okay. So that's it. So shall we continue the lesson? I'll give 2 examples, two more questions, live questions, and I'll discuss it just now, and then I can continue the lesson. So we have completed the basic part, okay? Alkanes, alkenes, alkynes, and benzene. Now I'll be continuing to the other organic compounds, which is very useful. Okay, the today's session, and by the next week's session, we'll be finishing the lesson. Okay, we'll be finishing the lesson definitely. Lesson means nomenclature part. We will be able to reach to the exam questions, past paper questions, and then the nomenclature part will be turning to the end. Okay. So still, this is not the exam nomenclature. I must say that. Okay. None of these questions they will be asking in your exams. These are very simple stuff. One question we can do, I think. Okay? Only one question. What would be that question? That's L. Okay. No, still not. That's not still possible. Yes. So I'll give one question. Yes. Try to draw the structure. 3 hept. Sorry, should be 2 hept. Okay. 2-heptine. 2-heptine. With non-3E. Notebook, question book. Okay, here's the questions book. I think you have done those questions in your questions book, no? So in the same book, do it. If you don't have any notebook and question book, you just have any one book. If you just have only one book, use that book. But it is better to do these exercises in your questions book. I told you to get 200 pages book for your questions. So that is what we are discussing. Okay? In notes, we just need only like 80 pages maximum. Right, molecular formula and then the compacted form. Okay, molecular formula MF, okay, and the structural formula in compacted version. The compacted version. So time is enough. Time is enough. So try to confirm your answer. Okay, try to look at your answer again. Check it again. So shall we discuss? Yes, heptine, 2-heptine. So 1, 2, 3, 4, 5, 6, 7. So it's better to number 1, 2, 3, 4, 5, 6, 7. I have seen some students when I'm giving heptine, they're drawing only 6 carbons. So that is not numbering, okay? Or that is not just drawing the proper number of carbons. Totally incorrect. 2-heptine means at the second and third carbon, you have the double bond. Sorry, heptine means the triple bond. So then the second and third carbon, you have the triple bond. That's it, you have to complete it. Okay. So when I'm completing it, I'll write it again and complete because I'll write in the compacted form. CH3, C triple bond C. That's it. So then no need to repeat these 3 carbons with CH2, CH2, CH2s. So it should be CH2 thrice, and then this is CH3. That's it. The molecular formula, Hep means 7, I means, okay, alkyne. CnH2n minus 2. 7 into 2, 14. 14 minus 2, 12. C7H12. So that is 2-heptine. That's it. Nonene, non-3-ene, 3-nonene or non-3-ene. Okay. I have just given this because I have given everything. I don't have anything to give again. Okay. So that's what I have changed it to nonene, but in exams you don't get this. However, okay. Now 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Always I'm double counting it because in order to confirm it. Okay. If you are losing the carbons, that is incorrect. So this should be between 3 and 4. 1, 2, 3, 4. So it would be here. Okay. Just put the numbers. Put the numbers, then you can confirm the availability of the double bond is correct. And then that is a single bond. Okay. So let's complete the structure. CH3, CH2, CH, double bond CH. So don't write CH2 here. Okay, that's incorrect. CH, double bond CH. That means when the double bond is at the center, it's in CH mode. When the double bond is in the corner, it is CH2 mode. Okay, you can experiment those. Yes. So then, how many carbons? 1, 2, 3, 4. You can write CH2 4 times, and then finalize with CH3. That's it. Okay. So then today's session we are starting. It will be a simple session. Okay. So let's discuss. Okay, let's continue. Yes, so I'll give that. I have given the number, the hydrocarbons as number 1. Okay, so hydrocarbons was number 1. So if you have expanded the numbers, excluding hydrocarbons, now alkane, that should be the number 1. Then alkenes number 2, alkynes number 3, and benzene number 4. So there can be 4 numbers like that. The actual notation, but it's better to write hydrocarbons as number 1. So it depends how we have numbered. Okay. So shall I ask one question from the student? Oshanika, how we have numbered? Is it 1, 2, 3, 4 or just 1 for hydrocarbons?
1, 2, 3, 4, sir.
Yes. So then already you have taken 4 compounds, isn't it? So alkanes is 1, alkanes is the second one, alkyne was the third one. Benzene, okay, keep the number at the benzene part in the very first page, I think. That's number 4. Okay, keep number 4 there. Okay, or get benzene as 1, and then alkanes, alkenes, alkynes as 2, 3, 4. However, you have to finish up to the first 4 numbers. Now I'll be starting from number 5. Here, yes, right, number 5, carboxylic acids. Carboxylic acids. So from here onwards, in order to discuss this stuff, we need very important notation. Yeah. Yes, number 5 is carboxylic acids. So from number 5 to number 14, we are discussing some compounds, around 14 to 13, okay, some compounds. So in order to write these compounds, we have to develop one common idea. So that's what I'm going to implement here. Now, please remember, we're going to discuss a topic, okay? I'm discussing carboxylic acids, but before discussion of the carboxylic acids, keep your topic, that's okay. Before discussion of the carboxylic acids, I want to explain you about some special groups called R groups. Okay, this is very important. Huh? So we are going to discuss about alkyl groups. Alkyl groups. They are known as R groups. R groups. R means the symbol for alkyl. Okay, alkyl R. So what means by alk? I think you know what is alk. Alk means a common name for the number of carbons. Meth, eth, prop, but, pent, hex, likewise. And we are having a note for alkynes and benzene. We didn't write any note for alkynes. I just thought that we have finished the alkynes. So if you have not written any note for alkynes, I think we have done only alkanes, isn't it? Benzene we discussed there. I have done the same lesson for 2 another classes, in the other 2 classes also. So in your class, we discussed about benzene, isn't it? Oshanika, benzene. We have drawn the resonance structures and all the other stuff. Yes, so that's benzene. We're not writing any more notes, okay? Because in my class, I'm not depending on my notes. I'm just depending on the theory session with questions, okay? So for benzene, you can search in the internet and get a bulky note if you want, but it's not required. I have given everything. Okay, just I can confirm. For benzene, that is enough. The Kekulé structures, resonance structures, and resonance hybrid. Okay, that's enough. Okay. In reactions part, I'll be writing reactions. Okay. You have to get the confidence after completing the organic chemistry session. Okay. Just before, in between the sessions, you won't be getting any sense. But for alkynes, we should write a note. Okay, definitely you should write a note. Just wait, if you have not written any note related to alkynes, please remember, I think you can put your self note, alkynes. Okay? It is exactly same like alkenes. So what you have to do, the common formula, CN, H2N, minus 2. So what's the first alkyne? Number 1, ethyne. Now I think you can draw this very simply because we have done the exercise. Okay. Propyne. In propyne, you can mention it as 1 propyne or propyne. And then in butane, you can mention 2 butyne. 2-butane, and another 2 structures like 2-pentane. And then 3-hexane. 3. Yes, so try to draw these structures. We have not written the alkyne note. First of all, it is the topic that we have written as carboxylic acids because we were going to start that part. But here we have to finish that. Okay, we have not done alkynes. So then under the ethyne part, you can draw the structure of ethyne like this. So it is C2H2, the molecular formula, and this propyne CH3 C triple bond CH. Now you can directly draw this. Okay, and you can write as C3H4. So likewise, try to complete the 2 structures. I'll give 1 minute. So what should be the order of your note? First benzene in the first part in the classification, and then we started alkanes, alkenes, alkynes. We should complete it, and then we'll be moving to functional groups. Under the functional groups, we'll be discussing R groups and all the other functional groups. So please note this down. Write the molecular formula and structural formula in your notebook. Okay, let's complete it. Okay, now I think you have the time in order to complete this. Butane, it's 2-butene. This was the structure. Okay, 2-butene. So if you are writing the formula, C4H6, C4H6, 2-pentyne. So you can see I'm directly writing that. CA3. Now focus from mine. 2-pentyne means in the second carbon there should be the triple bond. So I'm directly writing that. CA3, C triple bond C, because I'm numbering from this way. From my mind, I'm numbering from this way. 1, 2, 3, then 4, 5. Okay, and the other way also you can number. No issue. We're getting the other structure. Okay. CA3, C triple bond C, CH2, CA3. So pentyne, C5, H, 5 times 2, 10 minus 2, 8. 3-hexane, CH3, CH2, C triple bond C, CH2, CH3. Okay. So hexane, C6, H10. H10. Any issues? Yes, great. So that is alkynes. I'm not writing any more notes than this because I'm discussing more questions. So in my class, I'm getting the time to discuss questions, conversions, past papers, term test papers. So that's what I'm giving a summarized note, because the resource book is also available as an additional note. Okay? I don't want to repeat the resource book again. Just these alkynes. So let's learn about the topic that I was going to start. That is alkyl groups. Okay. Alkyl groups. So alkyl groups means R groups. Okay. They're known as R groups. So simply, it's an important task. Alk means number of carbons. Okay. Il means a suffix. Okay. Il means a suffix that we're adding. Alk means the number of carbons. So how do we generate alkyl groups? And what is the importance of these alkyl groups? Please keep remember, these alkyl groups are just like this. First of all, I'll teach alkyl groups and then tell the importance. So how to get alkyl groups? We have to take an alkane. First of all, you have to get the alkane like this. And then from an alkane, you have to remove one hydrogen. There are 4 hydrogens, you can remove any hydrogen. Not a reaction, but we have to keep that hydrogen away. Only the hydrogen, okay? Keep the bond, but lose your hydrogen, okay? Just put your hydrogen out. Any hydrogen, only hydrogen remove karana put. Now, this was methane. Okay? This was methane. But it's an alkane. Okay? So it's methane, 1 carbon methane. But if you are removing the hydrogen, you have to remove this N. That's the rule. If you are removing the hydrogen, you have to remove this N. Because now this is not a compound. It's a radical. It's a radical. Okay? It's a partial compound. Now you know carbonate is not a compound. Okay? Carbonate is not a compound. But sodium carbonate is a compound. Yes. Here the same. Okay? So I'm not telling this is an anion. This is a radical. A partial compound, okay, which is used to connect to another part and make a complete view. Okay. So this CA3 and this is meth. In order to indicate this as a R group, we have to add the suffix called methyl. So this is called methyl. So how you write it in short form? CH3 dash. Dash means this one. So why we need this dash? Because it suggests this part should be available in order to connect with another part. This is available in order to connect with another part. Now, if you are getting some toys, okay, in those toys, you have seen that in that part there's another small piece available in order to connect it with another species. Just think of your building blocks and remember. Okay. So, in a set of building blocks, there are equal parts with different colors. So all those equal parts are R groups. So you can connect the equal parts together. So how you decide that you can connect? Because there are some links, okay, it's given. some embedded ones. Therefore, we can just decide this could be placed in the other structure and we can make a new one. So these are the structures. So always it is not removing the hydrogen, the right side hydrogen, you can remove any hydrogen. But typically, traditionally, we are removing this hydrogen. So this is methyl. So do we have only one R group? No. We can have like 10 to 12 R groups. But basically, we are discussing like 6 R groups. Okay. Now this is methyl. So keep remember, you are deriving R groups only from alkanes, not from alkenes and alkynes. Now this is the second alkane. CH3, CH3. This is the second alkane. So the name of this alkane is ethane. Name of this alkane is ethane. So how to derive the R group from here? Just remove one hydrogen. Always I am removing this hydrogen, but you can remove any other hydrogen. So then the name is not ethane. If I am removing hydrogen, that would be ethyl. Ethyl. So how we write in the short form? We don't draw the structures. Okay? Keep remember, ethyl means CH3, CH2 dash. So likewise, you can get propane to get propyl, or propyl from propane, butyl from butane, pentyl from pentane, hexyl from hectane, heptyl from heptane, octyl from octane. Here, so it's simple. So don't mix up anything. Only you can use alkanes and just remove one hydrogen. Any hydrogen you can remove, but generally we are removing the hydrogen at this corner. Here, and don't forget to keep this bond. If you are not keeping the bond and if you are writing like this, it's incorrect. Because this will suggest this is like a compound. But there can't be any compound called CH3CH2 because the carbon is not completing the octet. So you have to suggest this is not a compound, it's a radical. This should be connected with another species in order to have a compound, and that is indicated by this dash. Clear? Okay. So let's write that thing. So here we are going to discuss carboxylic acids. So before carboxylic acids, we should know this topic. So write this one. Okay. Now, alkyl group. Okay. Alkane. Alkyl group. Okay. And then the name. Name. Okay. Now see here. What is the first alkane? Methane. CH4. Now I'm writing structures. I'm not going to draw the geometry. From CH4, just remove one hydrogen. So then you'll be getting the alkyl group CH3 dash. Okay. So then the name of this, the alkane is methane. But when you remove the hydrogen, that N is not available. So then you have to put the suffix for this il. Okay. So that is methyl. It is methyl. Okay. So let's get the next one. Ethane. Okay. Ethane, that is CH3CH3. Okay. So next one, propane. CH3CH2CH. This one, butane. CH3CH2CH2CH. And then it's enough to get up to butane. And then so these are referred as alkyl groups. Yeah. Alkyl groups. Other than the alkyl groups, we can discuss about an aryl group. What? Aryl group. Aryl. Okay. ARYL. Aryl group. So what is AR? Aryl. It suggests aromatic. Okay. This suggests aliphatic. This suggests aromatic. So we have only one aryl group. What is that? It's derived from benzene. So you know, in benzene, we have C6H6. In benzene, we have C6H6. You have to know we have 6 hydrogens out towards this. Okay. You have 6 hydrogens. So then, if we are removing one hydrogen, we can indicate it with a bond like this. Okay. If there's no hydrogen, you can indicate with a bond like this. This suggests there's no hydrogen. Okay, and it is trying to link to another compound. Okay. So if there's hydrogen, we don't want to mention. Hydrogen mention okay. So when the hydrogen is skipped, if you just have the bond, you can mention it like this. And what is the most important part? The name. So, for benzene, we can say benzene. Or for benzene, there's a special name called phene. Okay, keep remember. For benzene, we say phene. Phene or benzene, they are the same. Okay, so when you are deriving the suffix, when you are deriving the alkyl group, the aryl group from this, you have to remove the last name, and put il, and get some specific name which is easy to pronounce. Okay, pronounce karana bari name ganna bani. So then benzene and phene. So here simply in this benzene we remove this in. In phene we don't remove in. Okay, there's no in. So what we have to do, we have to put il. So it would be phenyl or either benzene. Okay, so it is called phenyl or either benzene. That's the point. Okay, so keep remember you have one R group that is from benzene, derived from benzene. Okay, so benzene is C6H6. So from that C6H6, we can remove one hydrogen. Okay, so this is C6H6. So when you remove one hydrogen, you get like this. Like this. It's known as C6H5. Like this. Okay, they're writing like this. In some printed documents, they are giving in C6H5. Because in order to draw benzene, you need a special talent when you're printing it. Okay, there should be a stencil, or otherwise you have to use a software. Okay, just like CorelDRAW in order to get these structures. From Microsoft Word, I think you can't draw benzene easily. Okay, so that's what the easiest form, C6H5. Okay, they're writing C6H5 dash. It suggests the benzene is substituted. Okay, so what is the name of this? It should be phenyl or phenyl or benzyl. Benzyl. The most common word is phenyl. Phenyl, phenyl or phenyl. PHENYL. Okay, I think you can fill these ones easily. Remove hydrogen from the end. Okay. Just here, CH3CH2. Don't keep like this. Put the dash. And then mention here you have two carbons, eth. That was ethane. Remove N, and then ethyl. That is ethyl. Ethyl. Okay, that fill the table. This is alkyl groups. Okay, first write this word, this sentence. We can obtain alkyl groups. We can obtain alkyl groups by removing a hydrogen from a given alkane. By removing a hydrogen from a given alkane, we can obtain alkyl groups by removing hydrogen from a given alkane. Okay, so don't think benzene is an alkane. That's what I have separated it, and I have mentioned aryl groups. Okay, so from benzene you derive aryl groups, while from all the other alkanes you are deriving alkyl groups. Okay, alkyl groups. Okay, please write it down. Okay. So if you have any questions, please ask from me. Aryl group. Okay, aryl group means benzene. මම අහන aryl group එක ආයෙත් explain කරන්න පුළුවන්ද කියලා. ඉතින් aryl group කියන්නේ මොකද? Benzene. Benzene means C6H6. In C6H6 we have 6 hydrogens. 1, 2, 3, 4, 5, 6. Aryl means from aromatic it's derived. Alkyl groups means from aliphatic. Open chain structures. From open chain alkanes you are removing hydrogen. So this is cyclic one. Alkane, and you have to remove one hydrogen from that. And removing one hydrogen from that. So we have 6 hydrogens. If you are removing one hydrogen, you have to indicate it. The hydrogen is absent. Okay? It's absent. It's not available. So that is C6H5. So the name of benzene is another name. There's another name for benzene that is called phene. Phene. Okay? Phenol, phenyl, okay? Phenyl. We have several compounds. Okay? Phenolic compounds. Phene means benzene. So then what do we have to do? We have to remove that. We have to get that phene term and add -il, that is phenyl. If not, sometimes we get benzene and remove -ene and add -il, that is benzyl. So we can refer benzyl or phenyl for this. Okay. So basically, you have to know these 4 alkyl groups: methyl, ethyl, propyl. Okay. This is propyl. CH3, CH2, CH2 dash. It's propyl. And here this is CH3, CH2, CH2, again CH2. 1, 2, 3, 4. Okay. So this butyl. Butyl. Methyl, ethyl, propyl, butyl. So can we shorten the alkyl groups? Sure. No issue. But generally we are not shortening it that much. But you can do. If you want, you can write butyl like this. CH3, CH2 thrice dash. Okay. CH3, CH2 twice, CH2 thrice dash. It suggests that is butyl. Okay. No issues. Okay. So now, so my point was to explain functional groups. Now the next functional group that we have to discuss is carboxylic acids. Okay. Carboxylic acids. Now carboxylic acid is a compound. It's a compound. So we can derive carboxylic acids, alcohols, okay, phenols, aldehydes, ketones, amines, amides, diazonium salts. In all those compounds, there's a common feature, the availability of alkyl groups. These alkyl groups are available when you are increasing the number of carbons. If you have only 1 carbon, sometimes you'll be using this alkyl group. If you have 4 carbons, you'll be using one of these alkyl groups. Now in the functional group also, we are having a carbon. Okay. Most of the cases in the functional group also, there's a carbon. I mean, apart from that carbon, there should be other carbons in order to complete the compound. So in that sense, you have to have the alkyl groups. So in organic chemistry, we are getting compounds. So a compound means a mixture of, a blend of alkyl groups with a functional group. Okay. So if you are mixing a functional group with an alkyl group, okay, alkyl group, it is a compound. It's a compound. Okay. So what I have to say, the alkyl groups are exactly the same. Always the alkyl groups are exactly the same. Now what I'm going to emphasize, the variable functional groups, the different functional groups. Now, first of all, I'll explain for carboxylic acids, what is the functional group? Then for alcohols, what's the functional group? Aldehydes, what's the functional group? But I'm not going to explain the alkyl groups again, because the alkyl groups are the same. They are the same. Is it clear? So I'll give one single example. Okay. So I have some now. These alkyl groups are just like some building blocks. Okay, like these ones. I have these ones in my home because the kid. Okay. So then this like alkyl groups, because these are common to any compound. I'm a compound common. Okay. So now we can keep like this and like this. Okay. And here. Okay. And like this, we can draw structures. Now this is a structure, so there's no name, but I have another one. Okay. Yes. So then there's no name again. Still there's no name. But this thing, I'm going to keep one functional group here. Now this is the alkyl group. This is the combination of the alkyl groups. Now I am keeping a functional group. Okay, it's another toy. Okay, so I'm keeping one functional group like this. So then this is one type of a compound. I mean, this is one type of a compound. I don't know. Right. So that's one type of a compound. Okay, like this. One compound, one single compound. So then I can make another compound by changing this functional group. Okay, then I'm trying to keep another one with this, okay, like this. Oh. So I'm telling this is another one. Okay. So just think I'm trying to make some wheels with this. So that means it will become a certain bus or a train like that. Okay. So if there's no wheels, we can make some boat or a ship like this. So what I'm suggesting, we have common structures. We have common units for all the organic compounds. They are known as the alkyl groups. Okay. So you can increase the alkyl groups or you can decrease the alkyl groups likewise. It's just increasing and decreasing the number of carbons. Finally, what we are doing, even we are getting one carbon, we can make a compound. But in order to make the compound, you have to attach this alkyl group with a proper functional group. Okay. So the second example, another example again. Now, the variation of the schools. Now, if you are considering a boy schools, your dress is exactly the same. The t-shirt and the trouser and sometimes the shoes, they are exactly the same. We can't recognize your school from your dress, okay, for most of the boys' schools. But how we recognize it? There's a functional group in your dress, in your clothing. So what is the functional group? Yes, can you guess? The badge or the type. Sometimes if you are prepared, we can guess that one also. Okay. So that is the functional group. It indicates the compound, the type of the compound. See there? So the same version, but from the badge, we can recognize the student, the school. Vehicles are also the same. Just think about cars. So the wheels and then the shape is almost like the same. So how you find out a specific vehicle? Always the badge is there. Okay. So from the shape, we can find out most of the times we are looking at the badge. So BMW, Benz, okay, Audi, likewise. We are not worrying about the shape and the color. Exactly the same. Okay. So in organic also, that will be same. Now from here onwards, I'll be discussing about different compounds: carboxylic acids, acid chlorides, amides, esters, amines, diisonium salts. Just the names are different. Like some cars, Toyota, Honda, Audi. Okay. Likewise, the structures are exactly the same. But what you have to keep remember. Now, in order to recognize a car, okay, which is an Audi branded one, okay, that one, you should know the brand with name. You should know the brand with name. Here also the same thing. We have to know all the functional groups with their names. So carboxylic acid means this is the block. And the name for the carboxylic acid is oic acid. Okay, oic acid. So there's a specific name. Ne? So we don't say that Audi car likewise. There's a specific name for that one. Okay. So in those schools also, specific names are there. Royalist, okay. Anandi, Nalandi. Okay. For different schools, you get different names, terms. Okay. So that's what the explanation, the background around this. Okay. So I'm trying to introduce the concept now. So if you have any questions, you can ask before discussing carboxylic acids. Yes. Can the benzene resonance structures form? Can the benzene resonance structure form aryl groups? Sure. Yes. Now in that case, you can draw the resonance structure also. Benzene with the circle and that one. Okay. The exact structure for benzene is actually the resonance hybrid. Okay. Resonance hybrid. Other than that, you can draw the resonance structure. For benzene compounds, there's no issue to draw this structure or the resonance hybrid. Okay. In most of the cases, I have seen this structure, Kekulé structure. You still be accepting this. Yes. So I think you have copied this down. We are going to start carboxylic acids. Okay, so alkane, alkene, alkyne, benzene, 5 carboxylic acids. Carboxylic acids. Actually, why we are discussing carboxylic acids first? Because I'm going to discuss these compounds in the prioritized order. Now, carboxylic acid has the highest activated groups among us all the other groups. Now we have alcohols, aldehydes, ketones. But among us those compounds, carboxylic acid are the most powerful ones. I mean, most activated ones. Activated one means the reactivity. It depends on the reactivity. So when you attach carboxylic acid to a one compound, it is highly acidic than alcohol or an aldehyde. Okay? So acidity is a certain function which we can understand the reactivities. Okay. So carboxylic acid, first of all, not this. This is the functional group of a carboxylic acid. COOH. COOH. Okay. We are expanding it furthermore. COOH. Okay. But we don't indicate this bond. We are writing it shortly. Okay. COOH. And what is this? Okay. So it is very simple. Okay. It is just like this. Okay. You know why we have this structure? Okay. Because in the other structures, we have this. So we can connect. That's what that is there. Okay. So here also we can draw like a hole and another like a small point. Okay. Always we are indicating using an dash. So this dash should be connected with some sort of alkyl groups like CH3 dash. Okay. And CH3 CH2 dash. So benzene dash. Benzene. This. Okay. So what are the compounds you can derive? Can connect this one to here. If you don't draw this much of large bonds, we are writing it very shortly, but I'm saying the concept. R groups are connected with functional groups. So then we will be getting the carboxylic acids. Okay. You can connect this one with this. Okay. And you can connect this one with this. Is it clear? So that's how we derive compounds. Very simple. Okay. But when you are connecting, don't connect like this. Okay. When some other students now CA3 this dash. And then in COOH, okay, we have this dash. So do we get any double bonds here? Okay. So this connects here and the other side, that hand. So then you are connecting like this, not this. Okay. So I think it's here. It's very clear. Okay. Explain questions. So now what you have write COOH and put this dash, definitely put the dash, and the name for carboxylic acids is oic acid. In carboxylic acid compound, we don't always say carboxylic acid, carboxylic acid, carboxylic acid. Then we don't want to keep it in our mind. So we are saying oic acid. So this oic acid suggests it's carboxylic acid. And what you have to study, oic acid means COOH. It's together. Okay? You can't separate it. COOH together, it's called carboxylic acid. This COOH is called carboxylic group. Yes. Okay? Carboxylic group. In IUPAC nomenclature, we say oic acid group. This should be oic acid group. Okay? Carboxylic is simplified into oic acid. Okay? So what's here? Here you can plus, here you can add the R group. Okay? But not always. In certain cases, we don't want to keep the R group. Instead of an R group, we can keep what? What do you believe? Instead of an R group, we can keep one species. What is that? Instead of an R group, okay. Now we are writing COOH like this. Okay. COOH we can write when we are getting compounds. So here what we have to place an R group like CH3. So then it will become a compound. Okay. So when you get COOH, you are placing an R group like CH3CH2. Okay. You are writing COOH. and you are getting a compound like this. But without any R group, we can keep it. But we have to put one species here. What will be that? Yes, exactly. It's hydrogen. In organic chemistry, if you're not writing any R groups, except carbon, you can put only one atom, that's hydrogen, in order to fill the spaces. Okay. Yes, so that's hydrogen. So I'm not always saying here you have to mention an R group. Okay. But if you're mentioning the R groups, you get compounds like this. Okay, then how to write the names? That's the most important part. Please understand this one also. When we are writing names, keep remember, we are starting the names or we are deriving the names starting from alkanes. The alkane structures, alkane names are very important when we are getting the fundamental names. Now see here how I'm getting the name. Now when you have one carbon, recall the alkane with one carbon. When you have one carbon, recall the alkane with one carbon. What was the alkane with one carbon? Methane. Okay. So methane. Methane. So is it methane? No. I know this is not methane. Okay. But it is derived from that. Okay. I mean, the name is derived from that way. Okay. So in this methane, what we have to do is keep remember. That's a very specific thing. Now, what is the functional group of the carboxylic acids? It's oic acid. So you can see this functional group is starting from a vowel letter. O. Okay. Starting from a vowel letter. O is a vowel letter. So what we have to do, we have to put this functional group to here. Now, methane, okay, methane, and we put this functional group to here. Methane oic acid. But we can't read it, no? We can't pronounce it. Methane oic acid. Methane oic acid. Methane oic acid. So then in that sense, what we are doing, we are releasing the last E. We are omitting the last E and attaching the vowel letter with this. So in most of the organic names, in organic cases, when we are writing names, when a vowel letter is approaching at the end, we remove the last letter. N, I, okay, E. We don't write the last E. We remove the E and attach oic. Because you can't read this name, methane oic acid. Those are not two names, one single name. So generally when you are reading it, you will be getting like methanoic acid. So in order to combine it, what we are doing as a rule, as an English language rule, we are removing the last E. Okay. So get methane and keep this one here. Methanoic acid. But remember, you have to keep a space between oic and acid. That's a must. Okay. So this is methanoic acid. It's methanoic acid. And then the name of this one. Okay. Before naming this one, here we have two carbons. What will be the name of this one? Yes, can you type it? Just consider the total number of carbons in the compound. See the total number of carbons, including the functional group. So count the functional group as one carbon. So now here 1 and here 2, we have 2. So that is ethane. Okay. In that ethane, remove the last letter. Don't write the letter and remove it. Okay. Okay, you don't want to write it, no? So then always we are doing that thing. So always do we get the functional groups with vowel letters? Most of the cases, except one functional group. In cyanides, we get nitrile. Other than that, all the functional groups are starting from vowel letters. I don't know why is it, but it is starting from vowel letters. Alcohols, all. Okay. Aldehydes, al. Ketones, on. AEIOE. Okay. So this is ethane. Okay. I'll write you two colors in order to indicate that. Ethane. We don't write E. This is ethanoic acid. Ethanoic acid. Okay, this one. So write its own. 1, 2, 3. Propan. Okay. Propane, we don't write last letter. Keep remember that's not an alkene. Nah? We don't get alkene structures. Sometimes you are confusing with this double bond. Alkene means carbon-carbon double bond. Alkyne means carbon-carbon triple bond. But this is COOH. It is clearly the COOH means oic acid. This name is given in order to indicate this part. No need to indicate the double bond again. So then this is propanoic acid. Propanoic acid. What would be this one? Okay. Now there's a special name. It's benzene. Benzene with oic acid. benzene with oic acid. So how we give the name? Okay. So we're making the name, we're softening the name. Okay. It's you can say phenoic acid. It's always mixing, sometimes phen and sometimes benz, it's mixing up. Okay. So in different structures, we get different names. Sometimes we use the term phen, sometimes we use benz. Both are referred. This is benzoic acid. Benz, we don't say benzene. Okay. And then we get oic, benzoic acid. It's a white color, isn't it? Okay, so that's the orientation. So I am not writing any notes. Huh? I'm not writing start the name from alkane, remove hydrogen. Oh, sorry, remove the last letter and attach this. That's what we are teaching. Okay. And then you have to practice it. Okay? You have to practice it. So methanoic acid, ethanoic acid, propanoic acid, and benzoic acid. And then I want to say there are some empirical names also. Empirical means general names. So for sodium hydroxide, the general name is caustic soda. Sodium bicarbonate, the general name is baking powder or baking soda. Sodium carbonate of 10H2O, the general name, empirical name is washing soda. So likewise, here also can indicate some general names. We get methanoic acid in organics for one single carbon. Okay, one single carbon, that's an empirical name called form. Empirical means general names, not IUPAC recognized names. Form. When you have two carbons, there's a term called acid. Okay. Acid is ACYT or ACT. Okay. Acid. Acid ACT form and acid. The other so for 3 carbons, 4 carbons, we don't have those general names. So what would be this name? Can you guess the name when you use form? Have you heard that acid? Should be formic acid. Yes, in biology, you have these terms: formic acid, oleic acid, lauric acid, okay, palmitic acid, acetic acid. Okay. Yes, so these are the common names, not IUPAC names. It's formic acid. Formic acid. So in organic IUPAC nomenclature, we don't accept these terms. Okay, it's a general term, formic acid. Keep a space. Then this ethanoic means it is acidic. Okay, this acidic. In vinegar, you have this one, acetic acid. Acetic acid. Okay. Propanoic acid and benzoic acid, we don't have names like that. But when there are names, I'll indicate. Okay, so please draw it, and then you can name this one also. This first example, second one, third one, fourth one, and I'll keep another one. CH3, CH2, 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 C double OH. Okay. C double OH. And I'll write number 6 also here. CH3, CH2, 2 times CO2H. CO2H. Write the names for these two. Okay. Just copy this down. Carboxylic acids. This number 5. Okay, so we'll discuss the next part. So what is this? Name of this one? Number 5. What's the name? 1, 2, 3, 4, 5. 5 carbons, including C-double-OH. So that is pent. And then the alkane is pentane, not pentene or pentine. It's pentane. Pentane can you have it? P-E-N-T-A-N-E. Remove the last letter and attach oic acid. So that is pentanoic acid. Pentanoic acid. What about this? Sorry, the 5th one. Huh? I have discussed. 1, 2, 3, 4, 5. The 5th one is pentanoic acid. What about this? So you have to expand it. Okay. As I have given, I have excluded, compressed. Now CH2 twice. That means CH2, CH2. So in most of the cases, for C-double-OH, we are writing CO2H. So, but don't expect this one as carbon dioxide. CO2 suggests okay, COO. When we simplify COOH, we can write as CO2H. Okay. So in order to indicate that, I have given it. So this is COOH. COOH. So Ca3, CH2, CH2, COOH. How many carbons? 1, 2, 3, 4. 4 means but. Okay. Butane. Butanoic acid. So it's butanoic acid. Butanoic acid. It's butanoic acid. That's it. Okay. So then let's move to the next one. Okay. So the same format will be following in the other compounds also. So keep remember this is not the nomenclature one. Okay. This is not organic IUPAC nomenclature. This is organic general nomenclature. IUPAC nomenclature of simple organic compounds. But in the exam, you don't get simple organic compounds. You get some complex organic compounds mixing alcohol, carboxylic acids, alkenes together in one single compound. Okay, any questions? So when methyl is the R group, it is called ethanoic acid. No, don't mix up. Now, when you are getting the names, okay, when methyl is the R group, is it called ethanoic acid? Not that thing. When you have one carbon in your compound, you should start with methane. Compound means the entire compound, including the functional groups and the R groups, everything. Don't separate the functional group and R group away and trying to get a name. You should know this is made out of a functional group and R group. But when you are getting your own name, when the name is obtained, you have to consider the total number of carbons. And then keep remember the, you have to recall the alkane. Now for two carbons, the alkane is ethane. That's how. Okay. Otherwise, you'll be thinking this is methyl, the functional group. Then would it be the methanoic acid or whatever it is? No. When you're writing the name, it's another approach. Okay. This is the R group, this is the functional group, but when you're getting the name, correct the number of carbons and recall about the alkane. Okay. Only the alkane. Yes, let's move to the next one. So what you have to keep in your mind, again I'm saying, oic acid means C-double-OH. Yes. Now we can increase the speed of this. Okay, how to talk speed layer compound figure. As you know the technique. Number 6. It is acid halides. Acid halides. What is acid halides? Let's find out. You know, halides means halogens. Fluorine, chlorine, bromine, iodine. So we can attach fluorine or we can attach bromine towards carboxylic acid. Okay. Now this is a carboxylic acid. So to this carboxylic acid, if you're attaching a halogen like fluorine, chlorine, bromine, generally we don't attach fluorine. We're discussing about chlorine and bromine. Okay. So we can remove this OH and attach Cl. So then this is called an acid chloride. Okay. Acid chloride. Or you get COBr, that's called acid bromide. Because it is derived from an acid, carboxylic acid. That's what the acid term is there. Okay. Acid bromide. Like this. Acid iodide and acid chloride, those are not available. Okay. We are not discussing. So acid chlorides and acid bromides, they are discussed. So what we have to place here, okay, generally we are placing an R group. Generally we are placing an R group. In some cases, instead of an R group, we can use hydrogen also. Only in some cases. Okay. Here we can use. So let's get some structures. Okay. COCl, H, CH3, COCl, okay. CH3, CH2, COBr, okay. CH3, CH2 twice, COBr, okay. And benzene, COCl. Okay. So then you should know, when we are writing the name, we have to know the name of acid halides. When you have COCl or COBr, how we refer? Acid chloride or either acid bromide. Okay. So generally it is called acid halide or chloride. Okay. Wait. When you are getting an acid chloride, the term is, can you remember in carboxylic acids what we have used? Oic acid. So here also we are having a certain term. It is called oil chloride. Okay. We don't say acid chloride. Acid chloride is the name. So the IUPAC term is oil chloride. As similarly, the carboxylic acid was the name, but the IUPAC notation was oic acid. So here also, oil means not OIL or YL. Oil chloride. And the other one here, this oil bromide. OYL, simple. Bromide, keep a space. Bromide. Okay, so I think you can write the names now. Shall we start with this one? Yes, count the total carbons. Don't separate the R group. Count the total carbons. So when you have 2 carbons, what is the name of the alkane with 2 carbons? Okay, so yes, with 2 carbons, the name of the alkane is ethane. So you can write ethane, okay, ethane, and remove the last letter. In ethane, remove the last letter. Because we are getting a vowel letter now. Now, oil chloride means starting with a vowel letter. So put it there. Exactly the same. No need to write any notes. So that is ethanoyl chloride. Okay. Ethanoyl chloride. So in the same manner, I think you can write all the other compounds as an exercise. You can start it. So this is benzene with this. So when you have benzene with this, that's called not phenol. It is again benz. Okay. So this is benzoyl chloride. Benzoyl, write it together, keep a space and write chloride. Benzoyl chloride. So it is up to you. Okay. First part we have write acid halides. And then write this one, oil chloride. This one, oil bromide. Then after writing this main case, include the examples, starting from here, example 1, example 2, example number 3, the name 4, 5. Okay, that is the way you have to follow. Okay, start doing it. You have to name yourself. Okay. Okay, shall I continue? Yes, what are the names? This one, HCOCl, which is discussing the UPCN with one carbon, that is methane, which take your answers, methanol chloride. Only one carbon. Here, how many carbons? Total carbons, huh? 1, 2, 3. 1, 2, 3. It is propane. The alkane is propane. So just consider the relevant alkane and add the suffix. Okay. Oil chloride or oil bromide. So remove the E. Propan oil bromide. Propan oil bromide. What about this? How many carbons? Okay. So this is one carbon. And here we have 2 carbons. And this one is 3. So 1, 2, 3, 4 means 4 carbons. It is butane. Butane. Okay. And then this is acid bromide. Okay. COBr, we can shorten like this. So there is butanoyl bromide. Butanoyl bromide. And this is benzoyl chloride. I think this is clear. So the next one, let's move. It is amides. Amides. So how many compounds? What is the number? Carboxylic acid was 5, right? Acid chloride 6, amides 7. 7 amides. So try to keep remember the functional group with the name. So how we notate an amide group, that is CONH2. CONH2. Like this. CO and NH2 should be combined together. Okay. Now I have seen some structures like this. COCH2NH2. Keep remember, this is not an amide. This is not an amide. Huh? This is not an amide. This is called amine, and this is called a ketone. These are 2 structures, two functional groups are available here. Some students, they are mixing up. This has an amide. No. In order to have an amide, both CO and NH2 should be linked, connected together. So then what is this? You know the meaning of this? It's the R group. So how we write the name of an amide? It's really simple. Amide. The name of the amide is amide. Both are the same. Okay. Some cases you get like that. So shall we write? Okay. So CONH2. 2 examples. So in this one also, hopefully you can put hydrogen. Okay. Instead of an R group, we can put hydrogen. In some compounds, we can't put that. Okay. You will get some examples later. And here CONH2 with CH3, CONH2 with CH3. Let's write a task. Okay, CH3, CH2 thrice, okay. And then benzene, benzene with CONH2, CONH2. I write another name here, CH3, CH2 2 times, CONH2. Okay, add the names of this. Add the names of this. It is just to you. Okay. Now creatively write it. I think you can write. Just write it. Okay. Now, as an example, first one. We have 1 carbon. So 1 carbon means an alkane. What is that? It is methane. Methane. Okay. So you know this is a vowel letter. So you can't write, you can say methane amide. Methane amide. So you want to make it together. Okay. So we remove the last letter E. Okay. And don't write cursive letters. Okay. Just write letters separately. Methane amide like this. So it's simply known as methanamide. Okay. Methanamide. And then this one, this can write. I'll give some time. This write. Okay, shall I get the names? Yes, this is methanamide. Okay? 2 carbons, ethane, amide, ethanamide. Okay, sinhaling ethanamide wage nikan kiyawenne ethane amide. Okay, now here CH3, CH2 thrice. Don't mix up. You have to use a bracket. How many carbons? Get the total number of carbons. Here we have 3 carbons. Here we have 1 carbon, and here also we are having carbon. So 3 plus 1, 4 plus 1, 5. So we have 5 carbons. So 5 carbons with amide. Okay. In amide form, it is 5 carbons means pentane. Okay. Pentane, removing the E and attaching amide. So that is pentanamide. Pentanamide. This Benz. It is benzamide. Benzamide. What is this? How many carbons? Total number of carbons. 1. Then here 2 carbons and here another carbon. Altogether 4 carbons. That is butanamide. 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 Okay. So let's move to the next one. The next one is very important. That is esters. The name of the esters, the nomenclating esters is a bit different and difficult both. Okay. So then you are going to realize one important nomenclature type, that is nomenclature of esters. Okay. Esters. So keep remember, this will be a different session than this. Okay. This pattern will not be available in esters. Again, this pattern will be continuing after esters. Okay. But esters, those are special type of compounds. They're having a different nomenclature. Okay, a different nomenclature. So the next one, esters. Ester. Okay. Carboxylic acids, esters. So then, whole group which includes CONH2. You can find out the question. What is the question? Is amide is the functional group, right? The whole group includes CONH2. Yes. Okay. If you get only this group, this is called amine. Okay. This is called amine. AMINE. If you get CONH2, especially it is amide. There's a variation. Both are functional groups. But still we haven't discussed this. We have discussed this. Okay, don't mix up. Esters. Now in esters case, so there is COO. Okay, so this is esters, COO. In esters, when we are writing the name, okay, so for COO, we can get an important term. The name is OATE. So when we are naming the esters, we are using the term called OATE. OATE, OATE. Okay. You can see we have given 2 lines either sides. Yes. Why we need 2 lines? Because here for esters we are applying 2 R groups. Okay. R1 and R2. That is the specialty. The carbon chain is not a continuous carbon chain. Now here you have a carbon chain, but when you are moving to the other side, there's an oxygen. You have to pass the oxygen in order to reach the other side. Okay. So that means there are 2 parts. This is just like a bridge in between the carbons. So in this nomenclature, either sides we don't have equal number of carbons. Most of the times in one side we are having a short group with an R group, okay? Like methyl, ethyl, propyl. Those are some smaller groups. Okay. But in the other side, we are having higher number of carbons, like 5 carbons, 6 carbons, 4 carbons. It depends. However, when you have that the shortest group, generally we are taking it to here. Okay. It's a small R group. Okay. This R group is relatively smaller than this, but sometimes they can be the same. They can be always the same. Some in certain cases they can be same. But in my experience, most of the times after this oxygen, you get a short R group. Okay, let's see how to name this. It's totally different. The nomenclature is totally different here. This part is only given by OATE. So can we keep hydrogens either sides instead of R groups? No. If you are keeping hydrogen here, this will become a carboxylic acid. Okay. And if you are keeping hydrogen here, it will become an aldehyde. So you can't use hydrogens instead of R groups in this notation. Okay. Yes. So the first ester. Okay. So can we get this name in this side? COO R1, R2. It's also the same. Okay. It's just the mirror image of this. So you can have COO this side or COO in the other side. However, you should keep remember to this oxygen, generally we are attaching a small group. Okay, small group. Okay, let's see how to name it. So when you are writing the name, you should understand the carbon chain is not continuous. That's really important. So because of that discontinuity, we are keeping a space when oxygen is there. For this oxygen, we are keeping a space. And then we are writing the names. Okay, see here how I'm starting. Huh? Now in this one, COO, we have CH3 and CH2, CH3. CH3, CH2, CH2. CO, O, CH2, CH3. COO, CH3, and this is CH3. Okay. CH3, CH2, CH2O, CO, CH3. And then benzene, O, connected to CO, CH2, CH3. And benzene O connected to CO, CH2 3 times, CH3. And finally, CH3, CH2, O, CO, and benzene. So this will be an important session for you. Okay. So I'll keep the camera to this side. Okay. Now, all the names are exactly the same procedure to follow. But I have seen most of the students, even their naming organic compounds really well. In esters, they are getting a certain mix-up. Okay? They are mixing up the nomenclature of esters. So out of the organic nomenclature sessions, the nomenclature of esters is the most difficult part. So that's what I'm going to explain now. Keep it well. Okay? Try to get it well. Yes. So here, definitely we are keeping a space. That's the number one I have to explain. Okay? We have to keep a space. Don't miss the space. See where we are getting the space. When oxygen is there, in order to explain the oxygen, we are giving a space. Okay? So space is given to explain about oxygen. We don't say oxygen. Huh? We are not writing the name of oxygen because this entire group, we are giving it as O8. O8. It's also starting with a vowel letter. Then from which side we have to start? So we have to number this. We have to number, but we have to know one thing. We don't number the group which is attached to oxygen. Okay? We don't number the group which is directly attached to oxygen. The group directly attached to oxygen. Okay? And we are starting with that. Starting with the group which is directly attached to oxygen. And don't number it. Write the alkyl name, the name of the alkyl group of that. What is the directly attached group here to oxygen? Is it the CO? That's the functional group. This is the functional group. This is the functional group. When CO is together, that's the functional group. You can see this is the functional group. Now here the functional group. So what is the directly attached group to oxygen? That's easily you can find out. So the directly attached group to oxygen is methyl. Methyl. You have to start with that. The directly attached group only work starting with the group directly attached to oxygen. So start with that, this CH3. So do we write the name from here to here? We don't write Arabic letters, so we are writing from left to right. Even the compound is from left to right or right to left. When we are writing our name, we are starting with the left side and writing the name to our right hand side, isn't it? Okay. So what we have to write first, the group which was attached to oxygen. So that is methyl. So write this group first, methyl. And then when you are getting the name, you have to get the name from this side, because we have to start from the group which is attached to oxygen and we have to write the rest. So then this methyl and this oxygen. So in order to indicate the oxygen, keep a space. Okay? Keeping a space to indicate the oxygen. We don't want to put dotted lines, huh? Just keep the space. So then what we have to do? Now count the carbons. But when you are counting the carbons, don't count this methyl group. Now you can count the carbons, but now when you are counting the carbons, don't count the methyl group. What you have to do? You have to count the rest, okay? Including the main functional group's carbon plus all the others. Take it together. So how many carbons we are having? 1, 2, 3, including the main functional group's carbon. Why we don't count this one? Because we have written the name. Now CH3 means methyl. Okay? So after writing the name, we don't want to write it again. We don't want to indicate another carbon. So this CH3 was given as methyl. So if we are counting like 4 carbons, again, we are getting a difference with the number of carbons. So this methyl was given like this. Okay. Now when we are naming this one, we are starting with this. What is this group? Okay. CH2CH. It is ethyl. And we are keeping a space because of this oxygen. And then we are writing the name. Okay. So what is the name here? Methyl. 3 carbons. So what is the name with 3 carbons? Alkane. 3 carbons, alkane. Propane. Propane. But what we have to do? We should remove the last letter as we are getting a vowel. In order to indicate this, keep remember COO. COO means this OH. Actually, this OH generates this oxygen and this oxygen. Because we are referring this carbon here with prop. Okay, but we are considering it together. Okay, so COO it is determined by this OH part. OH part. Okay, so definitely you have to count this carbon. If you're just getting 2 carbons and leaving this carbon away, that's incorrect. 3 carbons. 1, 2, 3. It is propane. Okay, so remove the last letter E and get your compound. Okay, so methyl propane and add this OH. So that is methyl propanoate. Methyl propanoate. Okay, what would be the name of this? There's only one name for here, and keep a space here. Okay, keep a space because of this oxygen. So always you have to start with the shortest group which is attached to oxygen. I can't say it is always shortest. Okay, the group which is attached to oxygen. So this is not the group attached to oxygen. You have the functional group, and after the functional group you have this thing. I mean the group which is directly attached to oxygen. It's easily find. Here you can find out. Okay, what is the name of this? I'll give 1 second. Okay. Yes. What's the name? Can you guess it? Try to guess it. Be creative. They're getting same names. Yes. So this is ethyl. Very good. Yes. You're receiving some names. Keep the space. Space. Don't forget the space. Yes. Ethyl. Then you have to refer 4 carbons. Okay. 4 carbons. Okay. So what is this? That is ethyl with, okay, ethyl with 4 carbons. Okay. Yes. Good. Very good. Ethyl butanoate. This ethyl. This one. Keep a space. 4 carbons. Butanoate. Ethyl butanoate. Okay. So, can you name these ones yourself? From where we have to start. Always, you have to start. You start with oxygen and get this group which is directly attached to oxygen. It can be anywhere. Now, in this case, it is in the right hand side. In this case, it's in the left hand side. However, it should be directly attached to oxygen. like this. So you can't say this is directly attached to oxygen. Huh? It's not directly attached. This is the functional group. Don't mix up this. The entire part is the functional group. Okay. So the group which is directly attached to oxygen is this. So what would be the name of this? Yes. Yes, very good. Receiving the names. CA3 means methyl. Yes, I know that is methyl. Then the entire name, keep the space and write the compound complete. Is it butanoate? Is it butanoate? 2 carbons. We have just 2 carbons. Okay. We have 2 carbons. 2 carbons means ethane. Okay. With ethane, you have to give the name. So this is methyl. And then you have to keep a space and name it as ethanoate. Ethanoate. So that is methyl ethanoate. That is methyl ethanoate. Okay. Methyl ethanoate. Okay. So when you have benzene, I'll give the name. Okay. When you have the benzene, what will be the name? So when there's benzene, for benzene, don't use benzyl here, use phenyl. The R group of benzene is phenyl. Okay. When it is acting as an R group, when you're getting the R group, that is phenyl. Okay. But when you are completing the name, that's like benzene. Okay. Let's see the difference. This is phen. Okay. It is phenyl. Phenyl, and then keep a space, and then complete your name with 3 carbons. 1, 2, 3. Okay. Phenyl with 3 carbons. So 3 carbons, what is the name? Propan. Yes, phenyl propanoate. Very good. Phenyl propanoate. So keep remember, we are writing OAT because of this. OAT. Prop means 3 carbons. Okay. Propan. This space means this oxygen. Instead of the oxygen, we have to keep the space. Okay, try to continue with the others also. So we have, I think, 1, 2, 3. Okay. You can do those 3 yourself. Okay. When benzene is attached to here, that is not phenoate. That should be benzoate. Okay. Like benzoic acid, benzoyl chloride. Keep remember this part would be benzoate. Okay. Yes, you can write it yourself. Okay, shall we discuss the names? Then any issues, please tell me. Okay. So you have given names, no? So this very important task. Methyl propanoid, ethyl butanoid, methyl ethanoid. This one. The name. Okay. This is not always the short form. Okay. So you can see how it is named. So always we have to start with this part. Starting with the group directly attached to oxygen. Okay. So directly attached to oxygen, this one. So what is this group? R group, methyl ethyl propyl. So that is propyl, methyl ethyl propyl. Yes, propyl, keep a space because of this oxygen, and then write the name for the rest. So you have 2 carbons. 2 carbons means ethane, and then put OH. So propyl ethanoate. So propyl ethanoate would be the compound. This one, it is again phenyl. And then how many carbons here? You can see here 3 carbons. And here there's 1 carbon and here there's another carbon. What would be the name of the compound? Yes, can you guess it? Phenyl, a space, how many carbons? So here 3, that's this 4, that's this 5. So we have 5 carbons. So 5 means pent. So recall the alkane of pentane. Then just remove E and attach this suffix. So removing E, attaching OH, that is pentanoate. So phenyl pentanoate. What about this? Again, you have to start from this. It is ethyl, a space, and the name of this one, you can directly write it. This is OH and this is benzene. So we're getting benzene and OH together. Benzene with OH, benzoate, benzoic acid, benzoyl chloride, benzoate. Okay. Benzoate. Ethyl benzoate. So that is the nomenclature of esters. Okay. So shall I go one another compound? What's the name of this? Benzene or CO with benzene. Yes, that's the name of this one also. Yes, very good. This phenyl. Okay, I have to start with this and then name this part. Okay. So these are really important ones. Okay, points. And you have to keep the space. Okay. So this is phenyl. Keep a space. This part is OH. This is benz with OH. It's linked. It's benzoate. Phenyl benzoate. Okay, so that was the difficult task that I explained. Okay, so it can be difficult or easy, but I'll be explaining in the same manner. So you have to work hard as you are getting the best levels. Okay, so keep remember, not this thing. Okay, in the exam, okay, in my exercises, I'll be giving the other format also. Now I can give the name and ask you the structure. I can give the name and ask you the structure. So shall I give one name and ask you the structure? Okay. Now just let's get another structure like butyl. It's a ethyl, butanoate. So now draw ethyl butanoate. We can give the name and ask you the structure. So in that case, how you start first? Okay, right? COO. at the beginning, like this. Then you can start your work. COO. Where should be the ethyl? And where we have to get butanoate. So this but means the total number of carbons. So from the total, already you are having one carbon. You can't miss it. Isn't it? Okay, please write the name. Write the name, draw the structure. To list. I'll give 1 minute. Okay. You can draw CO in any other way. Okay. Sometimes you can draw this one to here also. COO. However, the shortened group you have to put it here. Phenylethanoate. I have given 2 names. We have draw compounds. So it will improve your knowledge. Yes, if you have any questions, please ask from me. Same thing, okay? So this time. Okay, ethyl benzoate. So ethyl is the shortest group. Don't put ethyl here, that's incorrect. Ethyl should be attached to oxygen. Okay. That's what we are starting. So this is ethyl. Okay. Then that's all. Then butane means 4 carbons. So from the 4 carbons, already we are having 1 carbon. So when you are writing here, don't write 4 carbons here. Because 1 carbon is available here. We are counting with that. Okay. So then the rest is CH2, CH2, CH3. You can count and confirm it. Okay. 1, 2, 3, 4. That is ethyl butanoate. Okay. So if you are writing the name in the other direction, you can take COO, ethyl to this side also. This also ethyl. Okay. And when you are writing butanoate, you can write to this side. This is the first carbon, okay. Second carbon, the third carbon, and the 4th carbon. This is also correct. And you can shorten it also. Phenylethanoate. Phenyl means definitely benzene. Okay. But when you're writing the name, don't start with benzene. First of all, when you're writing a name of an ester, when you're drawing the name of an ester, write the ester form like this. It will make more familiar to you to this event. So phenyl, that's the short group, which is attached to oxygen. You have to place it here. Okay. Don't mix up this. And then ethanoate, 2 carbons. From the 2 carbons, already we are having 1 carbon. So then the other is here. That's there. Clear? Okay. So do we have to draw the oxygen lone pairs? It's better to draw the lone pairs. It's not compulsory. When you are completing a structure around oxygen, we have to keep lone pairs. But in organics, we are not worrying about that. Okay, we are not worrying about that. You don't want to draw the oxygen's lone pairs. Okay, that's not compulsory. Okay, so shall we move to the next structure? So we discussed about esters, and then we are going to get the next name: carboxylic acids, acid halides, amides, esters. 5, 6, 7, 8, and then ninth one, okay, should be aldehydes. Okay. Aldehydes. And the 10th one is ketones. Ketones. The 11th one, okay, we're going to get it as alcohols. Okay. Alcohols. So in alcohols, we'll be getting a special compound, okay, that is called phenol. Phenol. Okay. Okay. And the 13th one will be amines. Amines. Okay. So I'm going to extend several compounds now because these are a bit simple. Now aldehydes. Okay. In aldehydes, it is COH. This is the functional group. And then when you are getting this COH, how we shorten it? It is this name. The name is from here. Al. Okay, that's aldehyde. And then when you are getting ketones, keep remember the variation is COO. CO. Then you have to have two R groups either sides, R1 and R2. But here there's only one R group. One R group, just like carboxylic acids. Okay. Here we have two R groups. This can't be hydrogens. If this R group is becoming an hydrogen, it will be an aldehyde. So these R groups can't be any hydrogens. Alcohols as a functional group. Okay. In ketones, how we write the name, the main name. Okay. Ketones, this one is given by this. Okay. We are indicating this one by here. Now it is 1 or on. Okay. So we are indicating this one by here. It's 1 or on. It's given. Okay, so this is COO. It is on. It's on. So from ketone we can take it on, and from aldehyde we can take Al. Okay, so from alcohols we'll be getting all. Okay, alcohols we can get all. See here, R with OH. R with OH. This alcohols. R means the alkyl group. Okay, OH. So how we name the alcohols? Using all. Okay. How we name amines? That is NH2. NH2 is attached to a certain R group. Phenol, I'll explain what is phenol. Okay. Now let's write some examples. Huh? It's very simple. That's what I have given the variation. Try to keep it in your mind. Draw these functional groups in a separate paper and try to study. Draw the functional groups in a separate paper and try to study the variation. Definitely you should know COOH means oic acid. COO means OH, esters. CONH2 means amide. COCl means acid halides. We are writing it as oil chloride. Likewise, you have to know the variation. Okay? You can just draw a table. Now aldehydes, one of the examples. You can get COH. In aldehydes here you can mention, okay, this R group as a hydrogen. Okay? Instead of the R group, you can take a hydrogen and then you can keep CH3. Okay? In the same manner, you can keep CH2CH. Okay. Or you can keep benzene also. Okay. Benzene also. Like this. Okay. So let's find out the names of this. Simply aldehyde, we are finishing with Al. Okay. Al. So we have one carbon here. So when you have one carbon, there is methane. Okay. The compound is methane. Okay. I told you to recall the alkane. And then just remove the last letter E because this is starting with the vowel letter. That is methanol. Methanol. Sometimes we are saying methanaldehyde, but it is better to say methanol. Okay. Methanol. And there's an empirical name for this. There's an empirical name for this also. When you have one carbon, I told we can use form. We can use form. So some people they're saying formaldehyde. Formaldehyde. That's an empirical name. Okay. Formaldehyde. Formaldehyde. aldehyde. It's an empirical name, but the IUPAC name is methanal. So what would be the name of this 2 carbons? Ethane, okay, and L, ethanal. 3 carbons, propanal. Benzene with this, benzyl, or benzaldehyde, okay, benzaldehyde, benzyl or benzaldehyde. Okay, you can write this. Huh? In ketones, definitely you have to keep R groups. So in order to write a ketone, at least how many carbons we require? Okay. How many carbons we should collect in order to write a ketone? In order to draw a triangle, we need 3 sides. So in order to draw a ketone, in order to write a ketone, definitely we need 3 carbons. At least 3 carbons. Okay. Because either sides you can keep the shortest possible R group is this one. 1, 2, 3. So then how we name this? Actually it is propane. Okay. Propane is the alkane with 3 carbons, but you have to give the suffix with on. It's also starting with the vowel letter. What you have to do, you have to forget this E and write this one here. That is propanone. Propanone. But when you are moving to some advanced ketones, okay, now here the CO is available at the second carbon. Okay, 1, 2, 3. It's available at the second carbon. This is just like the double bond. So the advanced method of this one is 2-propanone. I mean best, okay. If you are writing the name at your best level, so you have to write 2-propanone. But when we are writing propanone, we know that is propanone means this one. Okay. For this one, the propanone and 2-propanone both are correct. How we get 2-propanone? By numbering. So what is this 2? 2 means the location of the CO bond, location of the functional group. In all the other cases, you can see the functional group is available with the first carbon. But in ketones, the functional group is always at the center. So because of that, we have to indicate the location of the functional group as we are indicating the location of the double bond. Okay? So I'll give one example here. Now see this one. CH3, CH2, CH2, CO, CH3. What would be the name of this? Now when we are giving this ketone, okay, we have 1, 2, 3, 4, 5. 5 carbons. So 5 carbons means it's pent. 5 carbons means it's pent. So then this is a ketone. So then you have to find in which carbon the on group is available. So we can't say it is pentanone. You have to specify the location of CO, because sometimes this CO can be here and sometimes this CO can be here. So what we have to do, as we have done in alkenes and alkynes, just number this. So can you number in any direction? No. You have to follow the rules. When we are numbering it, we have to give a lowest number to the functional group, okay, or the lowest number to the carbon-carbon double bond. So here try to give the lowest number to the ketone and then number it. So to which direction you are going to number? Is it this way? 1, 2, 3, 4? No. The other way. 1, 2, 3, 4, 5. Because we are giving the lowest number in that way. Is it there? So in that method, it suggests this CO is getting 1, 2, 3, 4, 5. This is 2 on. Is it there? So then how we name this? Okay. It is pent. Okay. It is pent. Okay. Pentanone, but which on? It is 2-pentanone. So we have to specify it like this, 2-pentanone. So if we get this CO bond here, we are mentioning it as 3-pentanone. Okay. Let's focus it. Okay. In ketones, you get that one. Alcohols. So shall we give several examples? Okay. You know alcohols very well. CH3OH. Okay. CH3, CH2OH. And then another alcohol. CH3, CH2, CH2OH. But if you get benzene, for OH, okay, it will be a different compound. And amines means here you have to place R groups. CH3NH2. CH3CH2NH2. Like this. Okay. And then we have the last one here. I can draw the last one here. No. Okay. I'll keep the last one in this corner. Okay. That's 14th one. Yes, I have to say. Okay. I'm going to give the exercise for you in this week, just like the last week. So that's what I'm trying to finish that part. So you can work with this, and you can do the exercise. and you can get ready for the next day's session. Okay, because in the next day we are going to discuss past paper questions, and we are going to start the nomenclature finalizing session. Okay, that means the past paper discussion. Before discussion, we have to write the note. Okay, yes. Now in this case, what is this alcohol? CH3OH. Very simple. Alcohol, how you are finishing with all. All. So what is this? You have one carbon. One carbon means methane. Remove the last letter. Remove the last letter and attach all. So this is methane. You remove the last letter E and attach all. So what is the name? Methanol. So this is the strongest alcohol we have. Okay. So in garments, when we are making clothes, when we are making dyes, we use methanol. Okay. It's not used for a beverage. Okay. If you are using this methanol as a beverage, you'll be getting blind. Okay. So then here, what is this? A well-known compound. Two carbons with all. Ethane, you remove last letter E and attach all. That is ethanol. This is alcohols. Okay. Generally in alcohols, you have 35%. Okay, to 40%, that much of ethanol content. Other is water, and in a beer, whiskey, it's like low percentage, okay, 8% likewise. So what is this? 1, 2, 3. So this is called propanol. Propan with all, propanol. Keep remember, propanol is not an alcohol. Propanol is available in your first aid box. Yes, see it. Isopropyl alcohol. Surgical spit. Okay, surgical spit. So you don't drink it. Okay, so propanol. And then phenol. Okay. When phen is attached to this OH, it is phenol. That's not an alcohol. It's a different compound other than alcohol. When you have Lysol, that's a type of phenol. It's a cleaning agent. Okay. Phenol. So then finally, amine, CH3NH2, it is methylamine. Okay. We can number that when as methanamine away. Methylamine. You're keeping a space also. Methyl means the function R group. Then here 2 R groups. Okay, ethyl. This is ethylamine. Okay, propylamine, butylamine likewise. And then 14. Finally, when you attach NH2 to benzene, if NH2 is directly attached to benzene, okay, like this, we don't say phenylamine. That's a one single name for this. It is called aniline. Okay. Aniline. It is called aniline. 14th one. Okay. 14th one is aniline, and we have 2 more compounds. Okay, I'll write it in the next day. I'll keep the names. Diazonium salt. And the 16th one is ethers. Ethers. Okay. Diazonium salts, ethers. Alkyl halides. Alkyl halides. I'll discuss about these compounds in the next day. It's very simple, but I'll discuss. Okay, so you won't be getting any exercise from this part. From these 3 compounds, but I'll be mixing all the other compounds in your exercise. Okay, so from here, where you have to write your note, I'll be adding a photo of this to your group. Okay, don't worry about that. Aldehydes, like this. Okay, this part. Then ketones. In ketones, don't forget the location of the CO bond. You have to indicate it. 2 propanol, 3 propanol, lowest number. Okay. Alcohols, methanol, ethanol, propanol, and the special type of alcohol is phenol. That's not an alcohol, a different compound. And then amines, methylamine, ethylamine. Methylamine and ethylamine, those are amines. And the special amine, when NH2 is attached to benzene, that is aniline. Okay. And I'll recall about this alkyl halides little bit. Alkyl halides, very simple. RX. Alkyl means R, halides means SX. So can you give me an alkyl halide? R, CH3 is an R group. What is an X? Halogen. So let's write chlorine. So this is an alkyl halide. What is the name of this? Methyl chloride. Like this. Methylamine, methyl chloride, ethyl chloride, propyl chloride, ethyl bromide, propyl bromide. Likewise, very simple. Okay. So ethers and isonium salts I'll explain. That's very simple. Okay. So we have discussed all the functional groups. In the next week, okay, please make a recall when we discuss isonium salts, ethers and alkyl halides. and complete your note. And I will send an exercise from this part. So please do that exercise today itself. Exercise. Okay. So until then, we're going to finish the session. So thank you.
Thank you, sir. Good night, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.